All right, welcome back. This is example 3. Still factoring polynomials, trying to solve them. The only thing different with this problem compared to the other two is the fact that I have 4 terms and now my biggest exponent is a 3. No problem. My goal is still to write them in standard form. What does that mean? That means I need to move the 4x to the left and the 4. What's going to happen is this side's going to cancel out and leave me 0. But over here, I've got kind of a log jam. Nothing combines, and that's no big deal because I want to make sure that I can still solve this. And when we saw this in previous sections last week, when I have 4 terms, my goal is to think about factor by grouping. And again, you can follow along in the notes on example 3 that are attached separately. I can factor out an x squared from this first group. And what does that leave me with? X plus 1. What can I factor out of negative 4x and negative 4? Negative 4. You got it. And what remains? That common factor, x plus 1. When I do this technique, I need to see this common factor show up. Because when I do, that means I'm almost done. That means part of my answer is that common factor. And the other part is what's on the outside, this x squared minus 4. What am I going to do with these two factors? Simple. I'm going to set each one of these equal to 0 just like I did the other examples. I'm going to do that over here to the side, got a little more room. X squared minus 4 equals 0. And then x plus 1 equals 0. Now hopefully this doesn't zoom in and out and get blurry on you, but if it does, my apologies. Just listen along. How do I get x squared by itself? Well, I want to add 4 to both sides. No big deal. But what times itself equals 4? The inverse operation to squaring is to take the square root. Now before you just jump up and down and say it's 2, well, you're right, it is 2. But it's also negative 2. Because a negative times a negative is positive. So whenever I have a square root, I have to now be mindful that it could have 2 possible answers, both a positive and a negative. Over here, simply subtract 1 from both sides, and I have x equals negative 1. Now, I told you earlier that this exponent, since it's a 3, tells me how many possible answers I could have. When we get to graphing, we're going to see that this particular graph has a funny shape and it could touch the x-axis in 3 locations. And that, my friends, is example 3.